Hi everyone, we're still solving trig equations in section 5.3. And we can use our old friends, the identities, like the Pythagorean identities. For example, solve 2 sine cubed of x plus sine of x plus 3 cosine squared of x equals 3. On the left side, you see that one of these things is not like the others. So then we have this idea of internal consistency, which I kind of mentioned in 5.2, internal consistency, making the pieces look like each other. So how can we make cosine squared of x look more like these guys? How can we write cosine squared of x in terms of sine squared of x? The Pythagoreans. I don't think cofunction will be as nice. So by a Pythagorean identity, we're going to substitute cosine squared of x with its equivalent 1 minus sine squared of x. Remember, that goes in parentheses. Whenever you do a substitution, be prepared to put grouping symbols. And here we have to put them. We distribute the 3. And we see that the 3's can subtract off on both sides. We're left with a 0 on the right side. And this might look familiar, especially if you substitute, put it in descending powers. It turns out we basically get the same equation that we got last time in our previous example. I'm playing one of my tricks on you. This is equivalent to the equations we dealt with in the previous example. We get the same solution set. Okay, so it was this over here, same solution set, because the equation here turned out to be equivalent. The point I wanted to make was that you sometimes apply identities, like the Pythagoreans, in order to get an equation we can solve.